Okay, I'm quite happy with this. All we need is the wheels, and I'm gonna leave this to you as a homework and fast forward this part. Let's go here at the bottom and define the pulleys that make the front wheel on the left. So this will be generated by a new method that we need to create. And it's gonna make the wheel appear at the quarter front left point with the wheel radius. And we also need to pass here the angle of the car so that the wheel orients in the same way as the car. This is easy to get. We can just calculate the angle between some front point and the corresponding back point. Like maybe we just take front left, the difference on y between it and back left, and the same thing on the x here. And this generate wheel function, let's just implement it down here. So a private method at the center with the radius and the angle. And let's first define a support, a segment that is going to be there where the wheel should be, centered on the wheel, but with the radius in the front. I'm just going to use a simple array here to group those points together. I think that a segment is overkill. And the first point is the center, and the other one, a new point, where relative to center x, we have to add the cosine of the angle times the radius. And the same thing goes on the y, but with the sine and the radius. And the z value for this point is just center z. Now, this wheel will have a lot of polygons there. So it makes sense to prepare for that as well. But I want to debug now. So let's just return an array of polygons. And the only polygon for now is going to be built on top of this support array of points to see where the support is and if we calculate it correctly. And we need to show this front wheel left polys somewhere. So now it's an array of polygons with just one polygon and one segment. But we do it here. I'm going to arrange this a little bit. And let's spread the front wheel left polys like so. And now if you save and refresh, we should be able to see here on the front left this small line appearing here. So it starts here, and based on the wheel radius, it goes up to this point. And now we have to make a circle appear around it like that, like if it would be spinning on the same plane that you see formed by this rectangle, for example. Of course, it's not going to be a real circle, just a polygon with many sides, but it does the trick, and I think it looks really nice. So let's start preparing those points like so. And now let's loop from 0 angle to 360 or 2 pi. And let's increase here by, I like to use a fraction of pi, so pi divided by 8 will give us 16 segments. And here let's push a new point into these points array. A new point where we have to figure out how to calculate the x and y and z. Now, I'm just going to type here lerp between the first point in the support, x, and the second point in the support, x, and then the cosine of a. Now, this cosine goes between -1 and 1, right? Because a is doing a full circle. And that means that here we will get values that are going to be also on the other side of the support center. So it's going to do the full range like that. when we add here a lerp for the y as well. So what this is doing is starting at a of 0, cosine of 0 is 1. Basically, that means we are here at the tip. And then it just follows this line all the way to the back here, and then all the way to the front, making drawing this line out of many points back and forth. We want to change the z as well, and we want it to be offset to this cosine. So what we do next is, relative to center z, we use the sine of this a, and we multiply by the radius. We don't need to multiply anything here because this linear interpolation is taking care of that part. So let's see what we get here. We can replace these points forming the support with the new points that we just created. Save and refresh. And you can see here that circle appearing there. But I want the wheel to have also a thickness. So this is really just one side of the wheel, really. Let's rename this function accordingly. And I'm just going to copy it above, like so, with the previous name. So this will be the new generate wheel that also has a thickness. I'm going to use a default value here, and let's just see how this goes. This function is going to call generate wheel side, and this will create the polygon for the inner side of the wheel. We don't need here an array of polygons anymore. It's just going to be one side of the wheel, so a circular polygon, and then the outer side of the wheel. So let's do that. I'm going to take a new center. Let's say center 1 is a new point. Relative to the center location, we just move to the side. So I'm going to use here the cosine of the angle plus 90 degrees. I want perpendicular to the direction of the car, and then times half the thickness, because we're going to have another polygon on the other side. And the same thing for y here, but using sine, and again offsetting by 90 degrees or half pi radians. The same way. And the z, we don't change the z. Now, copying this for the other side of the wheel, let's say center 2, all we need to do is replace this plus with the minus. And now we're ready to generate the two polys. So poly 1 is going to be generate wheel side on center 1 with the same radius and angle. And let's copy this below. This will be poly 2 with center 2. And this function will indeed return an array of polygons now. If we save and refresh, you can see both sides of the wheel appearing now. And up to you if you want the wheel to be part of the inside the car region, but I kind of like it to be half and half like that. Let's generate the sides as well, so the things that are forming that part. And it's quite easy. We've done this many times already. I just define a sides array and loop through all the points of poly 1, for example, like so, and add to these sides a new polygon formed by 4 points. The first point is going to be poly 1 points of I, and now poly 1 points of I plus 1. But because I want to loop at the end, I use the modulo trick and get it to work. Now the other 2 points are just going to be the same in reverse with poly 2. So poly 2 points length here, and then poly 2 points of I. Now these sides also have to go here, and I'm going to spread them. Save, refresh, and there you have it. Nice looking wheel. Let's add the others as well. So where we generate the front wheel left poly here, I'm going to copy this 3 more times. And this is going to be front wheel right polys based on quarter front right. Now here we'll have back wheel left polys and quarter back left. And this one is going to be back wheel right polys and quarter back right. And all these need to be used somewhere, like spreading them here. And then this one. And this one. Save and refresh. And there you have all the wheels now. But they're not spinning. We're going to solve that by passing the distance that the car traveled as a kind of offset to the angle we use when generating these sides of the wheels. You'll see. For that, we do need the information about the car when we extrude this car here. So I'm going to go here and pass best car to this function as a second parameter. And now going back to extrude car, let's add it here like so. And I'm going to call it car info because it can work with any car you want to extrude. We only show ours so that it's not too overwhelming. And when generating the wheel at the bottom here, we have to pass that distance that the car has traveled as the fourth parameter. And it's actually found in carinfo.fitness because the fitness we measure is essentially the distance that the car traveled. And it does go negative if it goes in reverse, so the wheels would also spin backwards. All we need to do is go to generate wheel and pass this distance here. The thickness stays the last parameter because it has the default value, and I will add the default value for the distance here as well, just in case. Now here we need to pass this distance also to the generate wheel side, like so. And here. And now use it to generate a new angle. Let's just call it angle A plus distance. Replace A here. Save the file. Refresh the page. And now when you go forward, the wheels are spinning, but insanely fast. And we have to do something about that. I'm just going to scale this distance by something, maybe 30. You could calculate precise values here, but maybe that can be your homework. I'm just going to eyeball it. This is too slow. They are spinning now too slow. Maybe 20. Yeah, this looks okay. I like it. What would be nice is to have the front wheels also turn, because I am turning the car, so the wheels should reflect that. It's really easy to do. We just need to calculate a different angle for the front wheels. So I'm just going to say this is the front wheel angle, and by default it's going to be car angle, but we're going to change it depending on several things. If we are playing the phone version of the game or the camera version of the game with the markers, then we have car info controls tilt to work with. And here we can update the angle by adding the tilt, and the maximum tilt would make it so that it's like 90-degree offset, so maybe that's too much. Let's divide this and see how it looks like. And then else, then we are playing the keyboard version of the game, so we have controls left, and then front wheel angle minus equals 0.3. This is how we update the car angle in the code. And if car info controls right, then the front wheel angle increases by that amount. Now let's pass this front wheel angle to the front two wheels only, even though some cars nowadays turn the rear wheels as well. And you can see now how the wheels are turning when I'm pressing left and right. Okay, good. Let's see if it works also for the camera mode. So testing quickly before the car runs away. Yeah, seems to work.